Hi, today we're talking about two problems on the Freelander TD4 diesel engine, same engine used in a lot of BMWs. One rare problem of it not revving over about 3000 RPM, and one quite common problem of it being difficult to start, especially when cold, and how you diagnose lack of starting. And the common problem on this engine was that the glow plugs had failed. So how would you test those, remove them, and basically fix the problem? We shall see shortly. First, to deal quickly with the revving issue. There's quite a lot of diagnosis that went on, I'll go through in a minute, to do with an engine not starting. But the problem turned out to be the crankshaft position sensor, which wasn't fitted correctly. I think the engine had been replaced. This is probably a recon engine or something. And these are the symptoms of how it behaved. The next stage in our investigation of why the engine is not running properly is to change over the crankshaft sensor. So locate it next to the starter motor, just underneath the starter motor at the front of the engine. It is possible to get to without taking off the starter motor, just about. There's one bolt with a recessed hex 5mm, I think. Underneath the engine, there's the bottom of the sump. Up by the flywheel, that is the crankshaft sensor, just underneath the starter motor. Like this. The sensor just pulls out like so. Hopefully you can see there's a little bit of a recess there. There we go, that's a good shot. Where the O-ring sits in, and the edge of the body of the sensor fits as well. So you can test the positioning of how it should sit. That is with the metal of the sensor sitting flat against the metal of the block, and I suspect the problem was last time is that the O-ring wasn't pushed all the way home, because the old O-ring wasn't flattened at all on its edges, which probably means it wasn't pushed into the hole, which probably means the old sensor was okay. But since this sensor is only 20 quid and I've opened it, we'll install it anyhow. And use your camera phone to check that the hole is lined up with the hole on the block, make it easier to get that bolt in. So in the end I changed it for a new O-ring, put a bit of grease on it, and made sure I could push it flat into the block before I inserted the bolt, to make sure that it was firm enough for a good seal, but also making sure that it's seated all the way home, as you can see there, with the metal against the metal of the block. That fixed the rev limiting problem. It does rev beyond 2,500 revs now, and that is with the original crankcase sensor. So obviously the problem was that the sensor wasn't fully seated home, so watch out for that. So why won't this Freelander TD4 start? It doesn't give any diagnostic codes on the OBD2 scanner, and according to forums that I researched, people say there's a couple of reasons why it wouldn't start without giving a code. One would be the crankshaft sensor. People also say it could be the camshaft sensor, which is this sensor here. We'll see if we get any change in the signal from the camshaft sensor. So it's 3 wires. My experience, normally these are Hall type magnetic sensors, where you have a ground, a power supply and a signal. So 2 of the wires have got the full 12 volts on, where this black probe is. See, I've stripped off the insulation. That one must be a ground, because this fatter red one has full 12 volts on, which means this must be the signal wire, and is currently about 11.6. I'll put it up here so we can see it as we crank over the engine. So let's crank it and see if that changes at all. As you can see, that does change, so it is giving a reasonable signal. Other things that people suggest are just cleaning up the contacts in these sensors, one here and the other one being the high pressure fuel rail sensor, which is down there. You can also put some probes and test the low pressure sensor, which you can see there right in the middle of the picture. There we go, that sensor there with that plug on top, that's the low pressure sensing. People get about 3.5 or 4 volts on that when that's working. But I don't think that's the problem, because I can hear the low pressure fuel pump working, and I can also hear it hissing through the high pressure pump as well. Sometimes you can get a problem with a split O-ring or seal on the fuel regulator, that connector right in the middle there. So some people have taken that off and checked the seals and so on. Haven't done that yet, but it's another possible as well. So I did start to smell a little bit of diesel fumes coming out of the exhaust, so I just got a better connection onto the electrical connections to the injectors by splicing through the cable like so on, and now you can actually see there is a reading going to the injectors, which we can see as we crank it over. It's only a small reading, but it is a reading. Which I think shows that the injectors are firing. So next we have to test our glow plugs, for which we need to take off the inlet manifold. We've got a bolt here, 1, 2, 3, 4 nuts here, and 1, 2, 3, 4, 5, 6, 7, 8 bolts at the top. Those can stay in place because they're held in by the plastic. Loosen off the connection to the exhaust into your EGR valve. This is a bypass EGR valve, by the way. And then, with a bit of wiggling, hopefully it should just all lift away. Right, is that disconnected? And then let's see what else we've got. We have got some sensor on the bottom, which we can get to in a minute. So we have a sensor here with the manifold air pressure sensor, like so. Right, then the whole thing lifts away. Right, that's the inlet manifold removed. So how do we check the glow plugs on the TD4 engine, the BMW M47 engine? This is in a Freelander. These glow plug connectors just pull off, and it basically is one connection from here to the ground of the engine. So we'll measure the resistance of each one, see if they still have the correct resistance, which means the heater element is still working. The resistance between the glow plug end and a good shiny piece of metal earth point on the cylinder block or on the cylinder head, and with a multimeter on a low resistance range, shouldn't get any more than a few ohms out of that reading. These ones are all open circuit, which means all of the glow plugs have all failed. No wonder it's difficult to start, so we'll have to replace the glow plugs. Anyhow, that's how you test to see if they're functional. You can also test it by taking them off. Here's the one on the right hand side taken off, and what you need to do is supply battery voltage between the main body of the glow plug and the end of the glow plug. You can see the insulating bit is in the middle there, and keep your fingers well away. You should see the end of the glow plug glow when you supply 12 volts, I believe. So that's how you test your glow plugs. To remove the glow plug, I suggest you put some WD-40 or equivalent around the end of the glow plug thread. Also use it to blast away any dirt, and then mop it up with a tissue. Make sure you don't get any dirt in the engine. You'll need a 10mm long socket, like so, and a wrench, obviously, to undo them. Do it gently because you don't want them snapping off. And it's just a simple matter of undoing, getting some new ones and doing them up. The torque for the glow plugs is 20 Newton meters or 15 pound-foot. So these are the original glow plugs, made by, in this case, Beru, made in Germany. All of them had failed, and these are the replacement ones I got very cheaply. I went for the cheaper versions, brick part ones, mainly because they're about £2 each, a couple of dollars or so in US money. So now we can test these for resistance with our multimeter on a 200 ohm scale. One probe to the body, one to the end, and as I say, you shouldn't get any more than a couple of ohms worth of resistance. So that's 0.7 ohms, and there's going to be some in the leads as well. The leads themselves are near enough the same. Yeah, so there's about 0.2 ohm resistance or nearabouts of the glow plug, so very low resistance you should have. So we'll just test all new ones are correct. Then we'll also test it on a car battery and hopefully see them glow, see how quick they take to warm up. Alright, so we'll take our car battery, a couple of leads, one to the body. Keep your fingers away from the tip because that's going to get hot. And we'll see how quickly these heat up, which I think is about 12 seconds. It's not as fast as some I've seen tested on the internet, but for the price, hopefully it'll be good enough. Here we go, connecting. 1, 2, 3, 9, 10, 11, 12. You can just see it starting to glow now. Yeah, let's get it a bit more. Yeah, it's glowing red hot now. I'm not going to overdo it. So they certainly work, and that's how a glow plug should look when it gets hot. Careful you don't get any muck in the engine when you're doing this. Right, let's see how well it starts. The engine is cold. Wait for the glow plugs to warm, the light to go out. Try starting. And again. That's crap. So, not the best start, but it did start, so good enough. So after a few days the Delphi ones arrived. As you can see here, the Delphi is on the right as an aluminium casing, instead of the cheaper one has some sort of brass casing. Slightly different length and slightly different thickness, as you can see there. They do fit the same, however. So let's see how quickly the Delphi ones heat up compared to the cheap ones. So for a set of 4, it cost me about £30 for the Delphis. Again, see my links in the video description for buying. These are from eBay. So let's see if we can time these, and what we're going to do is connect it directly across the battery. So to make sure that they both start up at the same time, you can see I've strapped both glow plugs together, each connection with a good bit of thick wire. That'll ensure they both come on at the same time, and we'll look for how quickly they start glowing. Ready, steady, go. Both smoking. The Delphi went straight away within 4 or 5 seconds, glowing nice and red hot. The cheap one is up to 12. It's only just now starting to glow as hot, 20 seconds. So there, that shows that the Delphi is a lot better. Disconnected, holding the heat near enough about the same. Big difference was the startup time there. So there you go. If you're going to get some glow plugs, I'd recommend paying a little bit more on getting the proper OEM Delphi ones. I tested it on a second pair as well, and the second time the Delphi one was even faster, at about 3.5 seconds or so before it started glowing. So consistently the Delphis are a lot better. Around 3 or 4 seconds, of course, is the time that the glow plugs normally come on when the engine is cold and it's cold outside, and so that's the time that you want them to start working in, which the Delphis do, and the cheap ones don't very well. Let's see how well it starts with the Delphi glow plugs. Glow plug light on only briefly. Pretty good. Not every cylinder lighting initially, but a little bit better than last time. Thanks for watching. Good luck with yours. Thanks. Bye.